Hello, I'm Kainton Genius, and today we are going to be performing principal component analysis using RStudio. So this is an application that is becoming very popular in the area of artificial intelligence and machine learning, and in this tutorial we are going to perform principal component analysis together using this application. So these are the topics we are going to discuss: our data sets. We're going to look at the goal, the objective we want to achieve by doing principal component analysis. We are going to preview the data. We are going to see that this data doesn't make sense until we carry out an analysis of this data. And then we are going to answer some analysis questions, and then we are going to load this data and then interpret this data. And then there is a method we are going to use called the PCA method. So just follow along as we do this together. Remember to click on the subscribe button so that you get updated when I make new presentations. Alright, this is our data set. It came from machine learning repository. So if you want to have this same data set, please click on this link, machine learning repository, and you can have this data downloaded to your system. Now data in this repository is in the R format, so it has extension .data. So let's just go there and see how it looks like. I've already downloaded it, but maybe let's just download it a second time. Okay, so this is the data. There are three items there: index, wine.data, and wine.names. So we go ahead to look at wine.data. So this is how the data looks like. For sure, it doesn't make any sense at all. So if I open the directory in my system where I have this data, I'll be able to open it using Microsoft Excel, and then we see how it looks like. So I save this here in PCA data. It's wine.data, that is the name, and as you can see, it doesn't make any sense at all. So let's try to read briefly about this data. It says the data consists of 13 parameters measured in 178 different wine samples from 3 cultivars. So what it means is that this data has 178 rows and 13 columns that that correspond to features of each of the samples that is measured. We also have 3 cultivars. Now I'm going to open this data in Microsoft Excel so that you understand the structure of this data. So if you have downloaded it as .data file, just go ahead to change the extension from .data to .csv. From .data you change it to .csv. That will be just fine. So at this time you can just say open with Excel, so you can see it opens. So this is our data we are going to analyze. So this column 1 has 3 cultivars. So the first one is 1, now you can see 2, and the last one is 3. So 3 different cultivars, or you can call it classes. So here you have about 13 different columns: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these are features of the sample. So this is cultivars using to produce wine. So this is a attribute or features of the wine that is produced from each cultivar. So for cultivar 1, this first sample here may have this feature, maybe alcohol content, may have hue, may have alkalinity content, and so on and so forth. So there are 13 of them. So if we want, we can actually add captions, but don't do that because we are going to use this data in RStudio. So just close it and don't save anything. Alright, so we are going to import this data into RStudio. Before we do that, let's just save it back with the same extension .data. Okay, that is fine. So now our goal is to analyze this data to check the patterns in pairs of variables, and then go through how to use PCA in R to plot PC1 and PC2. Remember, principal component analysis is an aspect of dimensionality reduction, where we are able to reduce the dimension of data to a few components that will enable us to visualize this data. So in this case, we are going to examine the two principal components. Remember, the principal components are the features of the data that maximizes the variance of this data. Alright, we've previewed our data in Microsoft Excel, and you see that it doesn't make any sense at all. Now, after analysis, the data is going to make sense, and we are going to answer this question that says which of the cultivars produce wine with a lighter color intensity, which of the cultivars produce wine with lower alcohol percentage, and so on and so forth. So we have the three cultivars. Let's call them CV1, CV2, and CV3. Alright, so let's now go to do the business. Let's open RStudio. If you have downloaded it, just go ahead to open it from your programs. If you've not downloaded it, just go ahead to download it from the website. Just search for RStudio download in Google, and then you can download it just for free. I'm going to clear my screen. Control L will clear the screen. So the first thing we are going to do is to load this data into RStudio. Remember, I saved it in a directory in my system. Right now we are going to load it into RStudio. So how to do that is using a command that says wine is equal to read.table. That is the syntax. So you say wine, you don't need to make any mistake, not really equality sign, but this other sign here, read.table. Okay, so if you've done this, then you go ahead to open the quotation, the double quotes, and then specify the directory that contains your table, or the directory where you saved it. I'll recommend you save it to your C directory so that it's going to be easy. So I call it PCA data / wine.data, and that is the name of the file. If you've done this, the file is now loaded into RStudio. So if you go ahead to type wine, you see that the file is there. You can see the table we visualized previously. So I'm going to clear the screen so that we continue. So now that we've loaded our data, let's see the next thing we are going to do. Okay, so the next thing we are going to do is to add columns and names and legends. So we are actually going to add columns to this data. So remember, this data is completely unstructured. We are going to now add columns to it. So the command to add columns is also very simple. So just follow along as I type this command. So what you do is you use the command call names. Call names wine. Wine is the name of the data set. Then you use this assignment operator and see the first column there is cultivars. Let's call it CVS, and then the second one is, now we specify the features. The first alcohol, followed by malic acid. Remember to put the quotes, malic acid. The next one is ash. Okay, the next one is alkalinity of ash. Alkalinity of ash. The next one is magnesium. Remember, I listed this in the PowerPoint presentation, so you can pause the video at that time and then copy it out with a pen and a notebook. Magnesium. I'm not sure I got the spelling correctly, but I think you can correct it yourself. Alright, so the next one is total phenols. The next one is flavonoids. Okay, that's fine. And the next one will be non-flavonoid phenols. Non-flavonoids. If you don't get the spelling correctly, that is fine, because this is not really the main thing, but try to make sure you type it correctly. The next one is proanthocyanins. And the next one is color intensity. The next one is hue. The next one is OD280 diluted fine. The next one is 0D280 of diluted. Okay, 0D280 slash 0D315 of diluted wine. Okay, then the last one is proline. I'm not sure I'm pronouncing these names correctly, but I think it's okay. Okay, so okay, we have an error there. I think we need to specify something. We need to specify something. When we loaded the data, we need to specify that it's a CSV, and that we can do by adding SEP is equal to comma. So this is what we are going to do. This is in the first line where you load the data. Just say SEP equals, and then in double quotes you specify this. Okay, so we can now use this. So now everything is correct. Alright, so the next thing we are going to do is to specify that the first column contains the classes. Remember, there are three classes: CV1, CV2 and CV3. Looking at the presentation, you can always see CV1, CV2 and CV3. So that is what we are going to tell RStudio, that the first column contains the classes. And how to do that is to just specify with the name wine classes equals, not equals, this assignment operator equals factor is equal to factor and wine, and then specify the first column, which we call CBS. Okay, so we've told RStudio that the first column contains the classes. Now we are going to have a preliminary plot of this data, and this is going to be a pairwise plot of this data. So this is a command that we are going to use. We are going to use pairs wine. So we are taking the first column to be a column vector, and so we have just one column for it. So we have -1, and then we specify the column to be equals wine classes that we already have defined in the previous line. Wine classes. Okay, so remember, we are trying to create a plot of this data. So this pair command has a number of attributes or arguments you can specify, so you can read it up, but that is not what this lesson is all about. So we want to actually visualize our data, so call equals 0.5, and that is fine. Oh, we had this. Okay, so the command is pairs, not pairs. So find classes. Okay, so I think we are getting it. So just correct the error. Okay, so so what we have here is a plot, but I think there is a little error there, so I'm going to correct it. So this is not called but CEX. Good, so now we have it. So this is a pairwise plot of our data. If you examine it carefully, you see that it makes some sense, though we are not seeing a big picture of this data. Okay, alright, so I'm going to zoom in so that we can actually view one of them. So for us to do that, what we are going to do, but before I do that, I would just like to add a legend to this plot. So to do that, you use the legend command. You use legend. Okay, so specify the location to be, I want it to be on the top right corner of the screen, and then bty. You can look up this on Google, and then legends equals CV1, CV2, and CV3, corresponding to the classes we mentioned earlier: CV1, CV2, always enclose in double quotes, CV2, CV3. Okay, so close your bracket. PCH, the parameter that has to do with the plot, is equal to 16, and then we specify the color for the legend data. So that we do by using COL equals C black for the first one, for CV1, and then red for CV2, and then green for CV3. Okay, so XPD equals TCX equals to Y dot intercept. Actually, this is the abbreviated form of the command, equals 0.5. Okay, so our legend is added, as you can see there. Alright, so now we have this plot, and we've come to an extent in our data analysis. So you can see that the cultivars are now separated, and we can see it visually. But let's try to zoom in to see a bigger picture of this. So let me delete that plot. To do that, I'll just say dev.off, and then I delete the plot. So let's have a bigger picture, and that we can do by using the command winepca. This time I want to use prcomp, which is a command for principal component analysis. Scale wine, and since it's a column vector, use -1, and then go ahead to close. That is fine. Then go ahead to plot winepca. WinePCA now is a variable that contains the principal component analysis. So we have 1, 2. Okay, so column is equal to wine classes. Okay, so now we have this plot. Okay, boys, seems I'm running out of time. I'm going to stop here so that we can move to part 2. So go ahead to move to the second part.